To our presentation today on case studies. We've got a diverse range of studies that have been undertaken using RapidEye satellite imagery in countries such as Brazil, China, Suriname, Guyana, Australia and New Zealand. Our speaker is Dr. Pete Watt, and he's a director of InduFOR Asia Pacific. Pete certainly has a very well-earned reputation in the forest resource assessment domain and in remote sensing. And for your information, the AAM group is a RapidEye distributor and has been working with InduFOR and RapidEye for several years. And we've had some great projects happening. So over to you, Pete. Thanks very much, everybody.
Oh, thank you very much, Gal. Good morning, everyone. What I thought I'd cover off today is how we at InduFOR have been using satellite imagery, and in particular, use of RapidEye. So I've got a number of case studies which I'll go through, and they're practical case studies, so they're principally aimed at solving resource mapping issues. So maybe to start with, we could cover off a little bit about satellite imagery in terms of where it's come from and where it's going, and maybe why, as a business, you should consider the use of satellite imagery to monitor plantation resources or just resources in general. So the main considerations really is that one of the main considerations is that image costs have dropped quite dramatically, and now you're able to acquire data quite frequently. So just for comparison's sake, the image on the left side, which is the red image, is a Landsat thematic mapper scene, which is 30-meter resolution. On the right side is the RapidEye scene taken at the same time. So you can see immediately you're able to glean a lot more information from a high resolution scene. Essentially, you're able to pick out different vegetation types quite easily. So the red image on the RapidEye image, the red area is plantation, which is radiata pine, and the greeny coloured area is a native forest. And in between, you've got a mix of bare land, grassland, and crops. Now, the idea here really is that you've moved in from something that gives you an idea of where it is by the 30-meter imagery to something that you can use operationally in your GIS system. So it's a high resolution scene at 5-meter resolution, covers quite a wide swath, so you're getting 25 kilometre by 25 kilometre tiles that are easily ingested into the GIS. And the other thing we've been doing at InduFOR is developing routines and software that takes the RapidEye imagery in particular and processes it through to evaluated products for monitoring and also mapping plantation resources and natural forest. So maybe first I'll cover off what type of activities we use satellite imagery for, and essentially these can be classed into two areas: strategic planning and due diligence. So that's where you maybe have less information about a resource and you use satellite imagery to improve the information base that you have. In forestry, that can be working in a number of countries across Asia Pacific, South America, and also Africa. The other aspect is long-term tracking and monitoring of plantation performance, or even natural forest areas. And that's principally looking at changes in the vegetation over time and working out change rates and tracking where the change is occurring. Also, compliance monitoring. There's a number of uses for satellite data in terms of monitoring whether people are adhering to good practice, and one of the common standards in forestry is Forest Stewardship Council certification. So that's looking at ensuring that people are adhering to sustainable harvesting practices. So the first application I'll cover is something that InduFOR has been working on. It's mapping plantation performance. On the left side you have the RapidEye scene, which is 5-meter resolution, and it has a plantation boundary overlaid on top. So you have the red coloured areas basically surrounded by the boundaries of the plantation. The plantation is a 30-year rotation, and it's established. You can see the success of the establishment as it progresses through time. And what you can do with the satellite image is generate a derived product. So it's basically a variation map. And the color-coded variation map shows red through to green. Now the red areas are areas that are recorded by the forest manager as stocked in the plantation register, but you can see that there's some bare ground quite evident in these areas, and that's shown by the blue colour on the satellite scene. So essentially we can build a model using the satellite imagery and relate it to what we expect the plantation to be growing like. So the model then runs a classification over the image and comes up with its colour coding. This can be applied across any crop, so it works with fast-growing eucalypts, for example, even oil palm as well. So the idea here is that you've given the forest manager something that is quite cheap, so the cost per hectare is very low. It's less than a cent to actually purchase the satellite imagery, and it allows a very quick and rapid overview of the plantation resource. And that enables you then to target these areas that are perhaps underperforming and take action to improve those areas. The other aspects then, this top slide on the left side is an area of plantation as well. So this is radiated pine again in Australia. And what you see is there's a grey mottling colour there, which is actually Dothostroma infection. So that has had a needle cast. So all the needles have dropped off, and you can see by the colour that it's very different to the surrounding plantation area, which has needles on. So the area with needles on is orange in this case. So easily identified this area, which you could then map out and maybe stratify in terms of the loss in volume, because with no needles there would be a decrease in the growth rate of these plantations. The second example is an area of wood theft in Brazil. So the forest manager had been covering this area with aerial photography 2 times a year. So with the RapidEye, you were able to pick up the area that is being cleared, and in this case it's been cleared for charcoal production. Quite frequently, given that you have the 5 satellites in the constellation, you're able to get daily coverage over these areas. Now you're also able to automate the detection of this area. So we have a routine that runs in the GIS that thresholds out the area that has been clear cut or harvested. The third example is an area of fire that has affected a eucalyptus plantation in China. So this is in Guangxi province, and this area here is quite steep, so it's probably average is 20 to 30 degree slopes, which make it very difficult to actually access these areas. So here you have the application is that you have an inaccessible resource, but you're able to monitor it frequently. In this case, the fire has escaped from a land clearance operation further to the west and encroached onto the plantation. This enables then this area to be mapped out, and either you would salvage this area or you'd replant it. In terms of natural forest areas, an area here of selective harvesting in Suriname. So this area is selectively harvested, and in that context you don't clear cut every tree. You take out selected trees over a hectare. You can see easily there that the areas where the trees have been removed is quite evident with the bare ground signature in the RapidEye, and the roads are obviously very clear. This is an area of white sand, so the background is quite exaggerated when the clearance activity happens. So the ground is the white. This enables here, maybe for compliance purposes, to monitor the spatial extent of the harvest area, and also to ensure that harvesting is only occurring within the areas that have been authorised for that particular year. The interesting point here is that countries in the tropics are often very cloudy, so the repeat visit of the satellite round about every day is very useful to enable quick characterisation of change. Same in New Zealand. It's again, it's a change activity that you're monitoring. Here it's an erosion event in a plantation area. Useful here to monitor the progression of the slip. So over time you can build from a baseline. So once you have a baseline of imagery, you can get repeat acquisition over the same location, which enables you to see how areas are actually expanding or whether you're able to mitigate the erosion by potentially protecting the areas by planting further trees. Same again, it's another monitoring application. It's this time it's a wind, what we call a wind throw event. So we've got an area here in New Zealand that has had snow damage or heavy snow loading and then wind on top, so the stems are broken off. And if you can see that slightly different colour to the surrounding vegetation or surrounding plantation because you're suddenly exposing the timber that's been snapped rather than the vegetation in the canopy. And that sort of monitoring can also be useful with repeat coverages of satellite data. So from a base, you're looking for changes in that over time. It may be of interest here is the application of, in this case, RapidEye again, for national coverage of countries. And in this case, we're looking at Guyana, which has 100% coverage of RapidEye, so it's about 21 million hectares. And the issue here is that Guyana is a very cloudy country. So to achieve a cloud-free coverage, you need multiple tiles over the same location. In the example here, we're looking at a mining site. So effectively, Guyana is monitoring forest change at a national level, and from that, calculating forest change rates. The idea that you use multiple seams, you use a combi tile solution, which means that you can have more than one tile over a location, enables you to minimise the effect of cloud cover. So to process that, over 21 million hectares requires around about 700 individual RapidEye seams. If the reason that you do it is actually to meet your reporting obligations. So in the case of Guyana, they have a 4-month window when to collect satellite imagery from August to December, and the report is released the following year by October. So in that period, you collect your data in the 4-month period, and then you do the analysis the following year. But at the current point in time, there's very few satellites available that would enable you to effectively cover a large area quickly and minimise your cloud impact. I'll just hand it back to Gail Kelly at AAM, and she'll cover off the RapidEye constellation and the main characteristics of the constellation.
A few words about the RapidEye system in overview. It's certainly best remembered, I guess, by its big 5 attributes. The RapidEye is a unique geospatial company that has 5 identical RapidEye satellites. Each of these satellites has a sensor on board which records 5 multispectral bands, and the most popular product is the 5-metre ortho imagery that's available in GeoTIFF format and supplied very quickly using FTP. So there's actually also an incredibly large archive of data. About 4 billion square kilometres of imagery are actually in the RapidEye archive now, since the satellite's been going around, or satellites have been going around since 2009. You can take advantage of this incredibly large archive and submit orders for areas as small as 500 square kilometres. You should certainly hop online, check out the RapidEye online archive search tool. It's called iFind. You can ascertain what great imagery is available over your project area. You can figure out the depth of imagery and the coverage that's available, because many areas have been imaged many times.
Okay. So really to wrap it up, I thought I'd put down some scientific references that the audience can perhaps go and have a look at, and all of them have been written in a way that have an operational focus, so they're really aimed at practitioners in forestry or resource assessment, and they cover off basically monitoring plantation resources and the particular applications for forest planning. Also there, if interest, are some LiDAR references, which in my mind you can complement this. RapidEye and LiDAR go very well together. RapidEye with the frequent monitoring at a low cost, and obviously LiDAR is slightly more expensive, but enables you to characterize the forest in 3 dimensions. Okay, well, thank you very much for your time, and that concludes the presentation today. If you would like any further information, then please feel free to contact either myself or Gareth.